Hello students, welcome to Edubbey Global Solution, and in our mathematics class we're going to be looking at another topic which is equation of a straight line. We have our interactive content here that will serve as a guide for this class. We have a prepared slide that consists of activities and as well as past questions. So, okay, now when you're talking about equation of a straight line, we have to know what a coordinate entails. So the general equation of a straight line, the coordinate of every point on a straight line has a common relationship. We made mention of coordinates in the previous classes where we actually deal with our y-axis and our x-axis with an origin point on our graph, which is 0. And we said that for a coordinate of the graph, we actually start from the what? From the bottom to the top, both on the positive and the negative axis for y and x. Now, the relationship when expressed algebraically as an equation in terms of x or y is known as equation of a straight line. In general, the equation of a straight line is written as we have y equals to mx plus c, where y is the value given on the y-axis and m is the gradient and x is the intercept and c is the constant. Okay, now we have an activity here based on the formula we have, which is y equals to mx plus c, right? We have to calculate this given expression, which is y plus 3 divided by 4 equals to minus x plus 2. So we have to arrange this in line with the gradient of an equation, which is y equals to mx plus c. So okay, now if you look at this equation, we have y plus 3 divided by 4, okay, equals to s plus 2, and we want this expression to take the form y equals to mx, okay, plus c. So what we just need to do here is first and foremost multiply this denominator by the term that we have here. So we have 4y plus 3 equals to 4 multiplied by what we have inside the term here. So we have y plus 3 equals to 4 times x will give us 4x, right? Okay, 4 times 2 will give us what? 8, right? Now we want y to be here. Look at this form of equation. So we are taking plus 3 to the other side and it changes to what? Minus 3. So we have y equals to 4x, okay, plus 8 minus 3. What is 8 minus 3? A minus 3 will give us what? It will give us 5. So we have 4x plus 5. And this, look at this expression here, y equals to 4x plus 8. It actually takes the form y equals to mx plus 6. And that is the solution set for this. So let's drag the right answer to the boxes here that we have. We have already told us that we have solved for y to be equal to minus x plus 5. So from here now, what is y? Y is what? Okay, y is minus 4. If you look at this example here, x is actually taking the negative aspect of it. So an intercept where it's going to be what? Intercept is going to be 5. Okay, so now we have 5. Okay, now let's check our arrangement. Yes, we are right. Now let's look at the next slide, which is equation of a straight line in the form of ax plus by plus c equals to 0. If you look at this equation, it looks like a what? It looks like a quadratic form of equation, but this one, the power is not in 2, so the power is just raised to power what? 0. So now a different form of equation is to rearrange the equation so that all the terms are on one side of the equation and the equation is equal to what? To 0, in which fraction must not be included. So when you have something, when you have any given algebraic expression and we have to write in this equation ax plus by plus c equals to 0, we must note that all the terms of that equation must be on the one side. Y0 is going where we are going to be equating it to 0, and fraction must not be included. Now, with that, we have an exercise there already worked out as an activity, but we are going to be solving the problem, which is what? The equation of a straight line is giving us y equals to 2 over 5x minus 1 over 3. So we have to write this in form of ax plus by plus c equals to 0. So we have ax plus by, okay, plus c equals 0. So and this equation that we have here is what? Y equals to 2 over 5x minus 1 over 3, right? So what we just need to do here is what? We have to bring y here. We look at the coefficient of y is in the middle here, so y must be in the middle of this equation. And by the time we bring y here, this turns towards 0, right? So okay, we have it to now be we have 0 equals to 2 over 5 x. So positive y will turn towards negative y because it's crossing the inequality sign. So y, okay, minus 1 over 3. Now if you look at this expression, it's more or less like the form of equation on a straight line. So and this gives us solution to this exercise that we have here. Now let's put down the right answers to each boxes that we have inside this activity. Okay, now we are to write ABC, and they are telling us that under quadratic equation as well, where we are using quadratic formula. We say that A, B, and C are what? They are integers value. That is, they can take a positive number and they can take a negative number, but they cannot be equals to what? They cannot be equals to, okay, 0. So we have this as integer. Now having that, okay, when we got to this place, now we have our expression to be in form of fraction, right? So if we have it in fraction, and based on the rules of that equation, which says that our solution must not be in fraction. So we have 2y. If you still remember, we have 2ix, okay, minus y, right? Minus y, isn't it? Minus 1 over 3 equals to 0. Now, for us to, what we need to do is what? To find the LCM of the denominator, which is 5 and 3. And the only best way to do that is just to multiply through. So the LCM is 5 times 3, which is 15. Now, after getting that, we are going to be multiplying each term by the LCM so that we can eradicate this denominator. So we have 15 multiplied by 2 over 5. We have x minus 15 multiplied by y minus 1 over 3 multiplied by 15 equals 0. So 5 can go in 15, how many times? That is 3, right? Okay, 3 can go in 5, how many times? That is 5, right? So we have 3 times 2 is what? 6. So we have 6x here. 15 times 5 will give us 15y, okay? 1 times 5 will give us y, 5, which is 0. And that gives us this new equation set. So now let's put the right answer in the boxes. By the time we multiply by the LCM, we have this as our answer 6x minus 15y minus 5 equals 0. Now let's look at parallel lines and their equations. Lines that are parallel must have the same gradient. We are still going to come into parallel line in our next slide. So what we just need to do is let's look at these activities. When you are having a line that are parallel, they must have the same gradients. Now we have these two set of equation here. This is one equation, this is another equation. With the first equation here is what? 4x minus 2y plus 1 equals 0, right? The second equation is 2x minus 4 divided by y equals 1. So we want to see how we can actually rewrite it in the form of the equation, which is y equals to my plus c. And let's see their gradient is going to be what? Is going to be common. What is the gradient here? M is the gradient based on our previous explanation. So this equation and this other one, we are writing it in this form. So we have y equals to mx plus c. That's our basis. So let's pick the first equation, which is yx minus 2y plus 1 equals 0. So we have to write it in this form. Then minus 2y will stay here and the others moves to the other side. So we can have it to be 4, okay, minus 2y, right, equals to, by the time it changes to the other side, we have minus 1, okay, minus 4x to come first. Based on this expression, then we have minus 1. Now, we have to divide through by what? Minus 2, because this is what we need here. So divide this side by minus 2, divide the other side by minus 2. Now, having doing that, minus 2 here, we cancel minus 2 here. Minus, we cancel minus here. 2 in 4 will give us 2. So we have y equals to 2x now. Now, minus, we cancel this one and turn this one to plus, right? Minus times minus will give us plus. And this will now turn to 1 over 2. Okay? Now, that is the first one here. Let's look at the second equation, which is 2x minus 4 divided by y equals 1. Now, what we just need to do here is we bring y to the other side. So having that, we can now say 2x minus 4 equals y multiplied by 1. That is 2x minus 4 okay, equals 1. If you look at it, okay, if you look at this place here, you see that the gradient for the first equation is 2. Okay, the gradient for the second equation as well, with this is also 2. So they have a common gradient based on the fact that what they are parallel lines. Now let's look at a question here. A straight line A, you ask equation y equals minus 3x plus 6. A second line B is parallel to A and passes through the point with its coordinates minus 4, 10, and 10. Calculate the equation of line in B. So what we just need to do here is that we have to express this equation as a form of a straight line equation, which is what? Y equals to mx, okay, ms plus c. So the first equation, which is line A, has actually been expressed in such form. But equation B, we just have the coordinates. If you look at this is our x-axis and this is our y-axis. So let's bring that equation in, which is y equals to mx plus c. Now from here, what is y? Y is 10, so we fix it in. What is x here? X is minus 4, so we have minus 4x, okay, plus c. If you look at this here, okay, minus, okay, m is what? We do m, so we have this now. 10 equals to, if from here, our gradient is what? Our gradient here is what? Is minus 3, because if you look like this is mx plus c, so y equals to mx plus c. So what we just need to bring here is, we bring the gradient here, which is minus 3, and we multiply it by, what is x value here? X value here is what? Minus 4, okay, plus c. So we are 10 equals to, okay, minus 3 minus 4 will give us what? That is give us plus 12, right? So we are plus 12 plus 6, that is we are multiplying 3 times 4, which is 6. Now, because we want to get c, we are bringing it to the other side, so we have it to be what? 10, okay, 10 minus 12 equals c. So having 10 minus 12 equals c, so we have it to be what? C will be what? C will be minus 2. Now, if you now remember, we can now write the equation line for B, which is mx plus c. So y is going to be, what is m from here? We have we said that from the equation, which is the first one, line A, m is 3, so mx, okay, so m is going to be 3 now, so you have it to be minus 3x. Well, our c, the answer for c is minus 2, so we have minus 2, and that is the solution set for that equation. So let's drag the right answers to this plus 6. After we are solved, we solve that c equals to what? C is minus 2, and the equation line for B will now be y equals to minus 3x and minus 2. Let's check. Okay, now that leads us to drawing straight line graph. Okay, to draw a straight line graph, only 2 points are needed. The 2 points will be plotted and the line is drawn and extended to both ends if necessary. So when we are dealing with a straight line graph, we just need 2 points, which is what? A point for y and a point for x. So now for this one, now we are going to be testing this equation. This equation is y equals to 2x plus 4. We want to plot this, so we are going to be testing the equation when x equals to 0 and when x equals to 1. What is y? Okay, now if that is the case, okay, now let's check what happens when x equals 0 and what happens when x equals 1. So we start with the first one, which is when x equals 0. Let's put it inside that equation. So we are going to be having y equals to 2x plus 4. So we are just picking it at an arbitrary point of 0 and 1. So it's not actually stated in that question. So y equals to 2 into bracket 0 plus 4. So 2 times 0 will give us 0. 0 plus 4, that's going to be 0 plus 4. Y equals to what? 4. So when x is 0, y is 4. So what happens when x is 1? We are just speaking at arbitrary point. We can pick when x is 2, when x is 3. So at earlier, but we are just picking on an arbitrary point. So we have y equals to 2 into 1 plus 4. 2 times 1 will give us what? 2 times 1 will give us 2 plus 4. Y will be what? Y will be 6. Now let's assume that we have a situation where x is 0 and y is 4 for the first answer, and the second answer is telling us that when x is 1, y is 6. So we see the plotting here. We have already written the graph on the negative axis for x and the positive axis of x. The same thing, positive axis of y and negative axis for y, which interval ranges are change of 1. Like 1 plus the 1 will give us the next one. 2 plus the 1 plus the next value will give us the next value. So when x is 0, y is what? When x is 0, we said that y is what? Y is 4, right? And when x is 1, what do we say? We say that x is what? Y is what? Y is 6. So, okay. Now, having that, we can now sketch our graph and it look like the graph look in this format. If you look at the point, we have the point here when y is actually 2, okay? And when y is 2, we have our x to be 2 as well. And that leads us to the next slide that we have here. Okay, now let's look at graph solution of a simultaneous equation. In our previous classes, we've treated simultaneous equation using different methods, elimination method, substitution method. So we are going to be looking at an example here where we have two sets of a linear equation and we have to solve both of them graphically. So under this point, we can decide to set an arbitrary point for these two equations. When x is 0, what is y? When y is 0, what is x? And at the same time, having doing that, we can also have, let's see, when x is when y is 0 for the first one. Okay, so x is going to be 4, right? When x is 0 for the first one as well, 0 plus y, right? So we have y to be also what? Y to also be 4, right? So for the first situation, we can have it to be 4, 4, right? Now let's check the second one. When x is 0, we have minus y equals to, so y will be what? Y will be minus 2, isn't it? And when y is 0, so we have when y is 0, so we have x minus 0 equals to, okay? So x will be equals to what? 2 here. So in this situation, we can have 2, 2. Okay, y is minus 2, so we have 2, minus 2. And we can also decide to solve simultaneously by bringing both of them together. So if we are solving simultaneously, let's use our elimination method for this one. Because we can easily do that. If you look at this, this is two different signs, so we are subtracting. X minus x will give us 0, right? Okay. Plus y minus y. Minus will give us 12. So plus y will give us 2y equals to 4 minus 2 is that 2, right? So we want to get y here, divide this one by 2, divide the other side by 2. 2 will cancel 2 here, and 2 into here will give us what? 1. So y equals 1. Now, we have been doing that. Substitute y equals to 1 in the first equation. We have x plus, we have 1 equals to 4. So we can have it to be x equals to 4 plus 1 changes to minus 1 by the time it crosses the equals to the side. So we have x equals to 3. So under this now, we can also plot on our graph. So the first point here is telling us that when x is 0 and y is 0, we have a point to be on 4 and 4, you can see here. And the second one is telling us that when x is 2, y is what? Y can also be minus 2. So when x is 2 here, look at it, but just sketch out here. Okay, now, so if we have that, then we can now look at, if you look at this, there's a point here, arbitrary point, which is when x is 3, let's trace it. When x is 3 and when y is what? Y is 1. If you study what we solved there under the simultaneous equation, you can see that we have that as an answer. Y is 1 and x equals 3. And that gives us the solution for that example. Now let's look at the next slide. What do we have? Okay, calculating the length of a line segment. A line segment is formed when 2 points are joined by a straight line. To calculate distance between 2 points, the coordinate needs to be given. Once these are known, then we can make use of what? Pythagoras theorem, and we use that to calculate the distance. And distance is calculated with that formula that we have there. The formula has actually been given to us. The formula is what? D equals to square root of x1 minus x2 raised to power 2, right? Plus y1 minus y2, everything raised to power 2. So that's the formula for calculating distance of a line segment. So having that, we have an example here. We have to calculate the distance between these 2 points, 1 and 3, that is x1 and x2, y1 rather, and 5 and 6, that which is what? X2 and Y2. So based on the formula for the distance, which is square root of x1 minus x2, we are raising it to the square plus y1 minus y2. Now from here, this is going to be x1, this is going to be y1, x2 is 5, y2 is going to be 6. So we are going to be putting that formula inside this and we are solving. So let's solve. Now from here, x1 is what? We have 1 and x2 is what? x2 is 5, so minus 5 all square, right? Now plus, what is y1? y1 is 3, right? Minus, what is x2? Minus 6. Remember, we are putting all square. Okay, d equals to square root of 1 minus 5, that is minus 4 square, right? Plus 3 minus 6, that is minus 3 all square. Okay, now minus 4 all square, that's going to give us 16. So we have to 16 plus minus 3 all square, that is 9. 16 plus 9, what is that? 16 plus 9 will give us 25. And what's the square root of 25? Square root of 25 is 5. And we have already sorted out the solution set here. So let's look at the activities here. Having solved, what is missing here is going to be 3 minus 6 will give us what? Minus 3. So minus 3 square plus minus 4 square, that is 16 plus 9, which is square root of 25. And root 25 is going to give us what? Give us 5. Okay, so let's check and let's see what we have. Okay, now we are having midpoint of a line graph. To find the x and y coordinate of the midpoint, find the mean of the x and y coordinates of that endpoint. So for us to, if we need a middle point, that's just the meaning of midpoint, you have to find the mean of the given coordinates. If you have x and y, x1, y1, x2, y2, you find their mean. And how do you get mean? You are just dividing whatever you are given, the total number number divided by its output. Like if you have 4, 5, 6, 7, how many are there? That is 4. Then you divide by 4, then you'll be able to get your mean. Now we have an example here. Find the coordinate of the midpoint of the line segment PQ, where P is minus 2, minus 5, and Q is 4 and 7. Here, x1 is going to be what? X1 is minus 2, y1 is minus 5, x2 is 4, and y2 is 7. So we want to pick the midpoint. What we just need to do is what? For the x-axis, we are adding x1 plus x2, then we divide by 2. And for the y-axis, we are adding y1 plus y2. We divide by 2. Why are we divided by 2? Because we just have 2 values here. So now for that one, x1 is what? x1 is minus 2. Okay, and x2 is what? Plus 4 divided by 2. Minus 2 plus 4, that is 2. Okay, 2 divided by 2 will give us 1. All right. Now let's look at the second one. y1 is what? y1 is minus 5. Okay, minus 5 plus what? That is plus 7. That is y2 divided by 2. Minus 5 plus 7, that is going to give us 2 divided by 2. 2 divided by 2 can give us what? 1. So the midpoint of this given question is what? Is 1, 1. So on x-axis this is 1 and y also is 1. Okay, now let's look at equation of a line through 2 points. What happens when we have 2 points? How are we going to solve the equation? Now we are told that the equation of a straight line can be deduced once the coordinate of the 2 points on the line are known. So now if you have the coordinate of x-axis and y-axis, we can actually deduce the equation of that line. So we have this question here. The point here where this is that to calculate the equation of a straight line passing through the points minus 3 and 3 and 5 and 5. So for here, x1 is going to be minus 3, y1 is going to be 3, x2 is going to be 5, y2 is going to be 5. So remember the previous class we have made mention of gradients and how to calculate gradient of a straight line. So we are going to be employing that, which is m equals to y2 minus y1 over x2 minus x1. Why are we doing this? Because we need the equation of a straight line. Now, if that is the case, then we can now say that what is y2? y2 is 5. What is y1? y1 is 3, so we have minus 3. Okay. Well, what is x2? x2 is 5, and what is x1? That is minus 3. So we have minus 3. So 5 minus 3, right? Which is what? That is 2, right? 5 minus 3, that is 5 plus 3, which is 8. 2 can go into how many times? 1. 2 can go in it, how many times? 4. So if you have this equation, y equals to mx plus c, which is equation of the straight line. M here now is what? M is 1 over 4. So we have 1 over 4x plus c. But before we go ahead, we need to get c. So for us to get c, we can just try to pick any of these points, either the very first one or the second one. So we are picking the second one for easy clarification. So we have, for this second one, we have 5, 5. That implies that our x and is 5 and our y is 5. So coming here, we have 5. Since y is 5, 1 over 4 multiplied by 5, okay, plus c. Now having that, we have 5 equals to 5 over 4x, okay, plus what? Plus c. We want to get c. What is, okay? We already said that x is 5, so we have 5 over 4. We want to get c. We are bringing 5 over 4 to the other side, and it changes to what? Minus. We have 5 minus 5 over 4. Now this has turned to LCM. The LCM of this one is going to be what? Remember, is equals to 6. So the LCM of 4 is 4. So we have 4 equals to, now this turns to 5 over 1. How many times can 1 goes in 4? That is 4. 4 times 5, that is 20, right? Okay. 4 can go in 4 1 times. 1 multiplied by 5 will give us 5 equals 6. So 20 minus 5. 20 minus 5 will give us 15 over 5 equals 6. Now this is an improper fraction. Let's quickly change it to this fraction and let's see. 4 can go in 15 amendment, that is 3. 4 times 3 will give us 12. And to remain what that is, it will remain 3 divided by 4, which is c. So we can now say that the equation of that given is what? No, we have it to be y equals to mx plus c. So we can now say it is y equals to 1 over 4x. What is c now? Plus 3 over 3 over 4. Okay, now that gives us the next slide that we have here. So now we are looking at perpendicular line. The rules for perpendicular line is that m1 equals to 1 minus 1 divided by m2. That is, gradient equals to 1 minus 1 divided by the gradient. That's how we calculate perpendicular line of any given coordinate. Okay, so now let's look at this example here. Okay, we have the perpendicular line that passes through this point is, we have minus 1 and 6. So we have to calculate the equations of this perpendicular line. Now I've told us that we said that we have it to be what? M, okay, m1 equals to 1 over m2, which is m1, m2. We are talking about gradients here. Okay, so from here we can now say that what is we have x as this and we have y as this. So for us to get that, what we just need to do, we have m1 equals to, we have, let's assume that our s2 here is 6, because that's for the position of what? Position of y. So you are going to be having to be 1 minus 1 divided by 6, and that is the m that we are going to be using now. Now having this, let's look at the equation of the point, which is y equals to mx plus c. We are told that our m is now minus 1 over c. Okay, now if you look at this, our y here is what? 6, and x here is minus 1. So let's put it inside that equation. 6 equals to 1 over minus 1 over 6 multiplied by minus 1. We want to get c here, which is constant, plus c. So we have it to be, by the time we have 6 equals to, okay, 1 over 6 plus 6, c rather. So 1 over 6 comes to the other side. We have it to be c minus 1 over 6 equals c. So having doing that, we can now say that find the LCM. The LCM is 6. So 6 can go is 1. How many times? 6 times 6, that's 36. Minus 6 in 6 is 1 times 1, that is 1 equals to c. So we have it to be c will now be what? 35 over c. So if you have to do that, the normal equation will now be y equals to mx plus c. So we have it to be y equals to minus 1 over c, which is the perpendicular line, x, then the constant is now 35 over c, and that gives us the equation of that perpendicular line. Now let's look at the past questions that we have here. We are going to be solving this past question. The first one says a is the point minus 6 5, and b is the point minus 2 and minus 3. Find the equation of this straight line that passes through the point A and point B. Okay, now first and foremost, we have to calculate the gradient. What's the formula for gradient? That is m equals to y2 minus y1 over s2 minus s1, and we need this value. Okay, so from here, what is x? What is y2? Y2 is what? Y2 is minus 3. Okay, what is y1? Y1 is what? Y1 is 5, so minus 5 divided by x2 is what? Minus 2 plus x1 is what? Minus 6. So we have minus minus, and that's minus minus will give us plus. So minus 3 minus 5, that is minus 8. Minus 2 plus 6, now because we have minus minus, that is going to be what? 4. 4 can go in it that many times, that is 2, but remember we have minus, so our m here is what? Minus. Now bringing that equation y equals to, let's put it to be minus s plus c. We need to get c, so we decide to pick any of the points here. Now let's pick the first point, which is what? Minus 6 and 5. So x is minus 6, y is 5. So we have 5 equals to minus 2 times minus 6 plus 6. So we have 5 equals to minus 2 times minus 6, that is minus, that is plus 12, right? Minus times minus will give us 12. So we have plus 12 plus c. 12 comes to the other side, you have 5 minus 12 equals c. So c will give us what? That is, c is going to give us minus 7 equals c. So we can now come back to that equation and say y equals to minus 2x, okay, minus 7. Now, if you look at the second equation, we have to find the perpendicular line. And the formula for finding the perpendicular is what? mi equals to minus 1 over m 2. Okay, so if you have that, what is our m here? Our m is minus 2. So we have it to be 1 equals to, okay, minus 1 over 2. And it will cancel each other. By the time it cancels each other, it's going to be m equals to 1 over 2. Now, putting that in the equation, y equals to mx plus c, we can now have it to be y equals to 1 over 2x, okay, plus c. Now, let's look at the next past question that we have here, and let's solve together. Now, we have this equation, y equals to 5x plus 6. We have to write the gradient, which is m, and after writing the gradient, we have to find the coordinate of point when the line crosses the y-axis and coordinate of point when the line crosses the x-axis. So look at this. This y equals to mx plus c. That's the equation set. So if you look at this, okay, here you can say that 5 is m. So m here, which is the gradient, is 5. Now the next thing is to look for the coordinate when y on y-axis. So if we set an arbitrary point of x equals to 0, y is equals to 0, what happens? So when x is 0, what happens to y? We fix it inside this equation and we solve. Y equals to 5 and to bracket 0, x is 0 plus 7. So that 5 times 0 will give us 0. So 0 plus 7, that is y equals to what? 7. So on that for the coordinate point of y-axis is going to be x equals to 0, y equals 7. And for the x-axis, let's see, 0 when y is 0, what is x? 5s plus 7. So 5s come to the other side. We have 5 minus 5s equals 7. We are dividing both sides by what? Minus 5. We have 5 minus 5. So we cancel minus 5. So our x is going to be minus 7 over 5. Now on the x-axis, when y is 0, x is minus 5, minus 7 over 5. Now, this takes us to the end of our class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class. Thanks for listening.